Alright, in this video we're going to try to take a look at collecting some simple data in the Boyle's law experiment. Boyle was interested in studying the effect of changing the volume of a gas on the pressure of that gas. He actually did it in reverse. He changed pressure and measured the effect on the volume. But we're going to use a simulation where we have a gas, in this case we're going to just use air, that is trapped in this syringe. And we're going to move the plunger on the syringe up or down, which will affect the pressure of the gas inside the syringe. The pressure will be measured here on this device at this pressure gauge, and then we'll see it in the table on the right. If you want, you can copy the data down, which is going to be useful, and then we're going to look at how to analyze the data using a graphing calculator. So you want to put a title, Boyle's Law. You'll want to make a note that we're studying the effect of changing volume on the pressure, and while holding temperature of the gas and the amount of gas constant. Remember that there's four variables in gas laws: pressure, volume, temperature, and amount, or moles of gas. If we're going to study pressure and volume, we have to hold the other two variables, the temperature and the amount of gas, constant. So set up a data table with volume measured in milliliters and pressure. The simulation is going to use a unit that's a little bit antiquated, pounds per square inch, PSI. So let's collect some data. We're just going to move the plunger up until the volume shrinks, and we'll collect about 6 or 7 data points. So there's the first one. Now if you want to round off your numbers to 1 decimal place, that's probably good. So 7.3 milliliters, the pressure was up at 70.7 PSI. And we'll just do that several times. So there's 2 data points. There's 3 data points. Collect a few more. 4, 5, 6, and maybe one more. There's 7 data points. So let's be sure to copy them down, because we're going to need to enter these values on our graphing calculator in just a moment. Alright, so I've switched views now to my graphing calculator. This is a TI-84 that's being emulated on my computer. The same instructions that I'm going to show you here will work on a TI-83, any version, TI-84, any version, and I think on the TI Inspires it's pretty much similar as well. What we want to do first is we want to enter the data that we collected just a moment ago. So right here in the middle of the calculator screen, let me just clear my keystroke history here. So in the middle of the calculator there's a button that says Stat. I'm going to press that button there, Stat. Now you'll notice on the right it'll show you here the buttons that I'm pressing as well. So there's the Stat button, and you see there's some options here. There's an Edit menu, there's a Calc menu, and there's Tests. In this course we're going to use the Edit and the Calc menu, but today we're going to just use the Edit. So option number 1 is Edit under the Edit menu, so I'm just going to press 1 on the keypad down below. That brings me to the screen where I see different lists, list 1, list 2, list 3. If I press the right arrow on my keypad on the calculator, I can go over and see lists 4, 5, 6, etc. If your calculator, by the way, is missing some lists, simply press the Stat button again and choose option number 5, which is Set Up Editor, and then press Enter, and that will restore any missing lists. So we press Stat, we choose option 1, Edit, and now we're at the lists, list 1, list 2. If there are already some numbers in here, suppose you had some numbers entered in the list and you want to delete them, then simply move your cursor up until it's on the L1 symbol like you see there, and then press Clear and Enter, and that will delete all the numbers that were in that list. So one more time, if there's some numbers in the list already, you want to get rid of them, move the cursor up until it's on top of the L1 or the L2 symbol, press the Clear button, and then Enter to delete them. So I'm going to just enter my volumes in list 1, so you can do this as well. So 7.3 milliliters was the first volume. I rounded off to 1 decimal. 13.6, 19.8, 23.9, I think. My writing is a little messy. 28.0, 31.4, and 34.5. Those were my volumes. In list 2, I'm going to enter my pressures, again rounded to 1 decimal, so 70.7 psi. Now, did you notice when the volume was smallest, the pressure was highest? That hints at what kind of relationship is that there exists between pressure and volume. So 38 psi, 25.9 psi, 21.5, 18.4, 16.4, and 14.9 psi. Just double check that you have the same number of numbers in each column. If you don't have the same number of x values as y values, your calculator is going to give you an error called dim mismatch, because it can't graph where there's no y value. It can't graph an x value. So it's going to give you an error message if that happens. Okay, I'm just going to clear the screen here. So we'd like to now create a graph, but not a graph of a function. You know, if you wanted to graph y equals x squared, there's a button here, y equals, and you could type in a function here. But we don't want to graph a function. We want to graph data. We want to graph a scatter plot, really. On the graphing calculator, that's called a stat plot. And you can see right up here above the y equals button on the top left of your calculator that says stat plot. Now on my calculator that's in blue, and the second function button is also blue, so I'm going to press second function stat plot, and that'll take you to this screen. Alright? Now, there are 3 plots we can make. We can make up to 3 scatter plots, plot 1, plot 2, plot 3, and then we can turn them all off, which is what option number 4 says. If any of these right now are already turned on your calculator, if they say on here, for example, if number 1 said on, you could simply press that, choose that stat plot, so I chose number 1 here, and then right here on and off, notice on mine off is highlighted, you would simply use your arrow button on the calculator to move back and forth until you were over the off button, and you'd press enter to turn it off. So what we want is we want to make sure that when we start off, all of the plots are turned off. So let's go to the first stat plot, and I'm going to now turn it on. I'd like to use this for my first graph. So my cursor is on above the on button, so the on word. So I'll press enter, and now I've selected on. There are 6 different kinds of plots we can make. The first one is the scatter plot, and that's the one I'm interested in. So I'm going to just scroll down with my arrow. So I've selected that plot, and then it asks me, where is your x list? Which of the lists, list 1, list 2, list 3, etc., did we have our x values in? Well, I'm going to want to make a graph of pressure on the y-axis and volume on the x-axis, so my volumes are in list 1 already. If I wanted to change this, if it says L1, but I suppose my x's were in list 3, then I would simply press the second function button on the calculator, and then down on the keypad above the numbers 1, 2, 3, 4, 5, 6, you'll notice it says L1, L2, L3, up to L6. So second function number 3 would change the x list to list 3. So in ours we weren't list 3, we were list 1, so I'm just going to go change that again. And our y list is list 2. We don't need to change that, but we now know how to do it. A common mistake when people make a graph on this with a scatter plot, with a stat plot, is to now simply press the graph button. If I do, I'm almost certain not going to see the graph that I wanted. What it's going to do is show me the previous graph or the previous window settings that from an earlier graphing experiment. So what I want to do is choose the zoom button, which is right here in the middle, right under the screen. Press that zoom button, and when you scroll down the zoom button, you'll notice there's an option number 9 which says zoom stat. Once you've done this several times, you don't have to scroll down. You can just press the zoom button and then option number 9 on your keypad, and what that does is it automatically adjusts the window settings to display the data that we put in lists 1 and 2. So what we're getting is this curved set of data points. Now to see the window settings, if you're interested, there's a button here called Window. If you click that window button, you'll notice it shows the minimum and the maximum of the x's and of the y's, and it shows you the scale, what they're going up by on the graph window. If you want to adjust that, you can. For example, my x minimum, maybe I want it to be 0, a nice round number. I'll go down to the x maximum, maybe I'd like it to be 40. The calculator, when I chose zoom stat, it simply uses these odd-looking numbers to encompass all the data on the screen, and now I'm just adjusting it. So my y minimum, I can also say 0 if I want. My y maximum, maybe I'll say 90. Now notice the scales. If I go back up to scales, my x minimum and maximum 0 to 40, maybe I'd want to go up by 5 in between. So if I were graphing that by hand, there'd be a tick mark at 5, 10, 15, 20, so it'd be about 8 tick marks. On the y-axis scale, y scale, if I'm going from 0 to 90, maybe I'd want to go up by 10s, so there'd be 9 tick marks there. The scales are not that important because we don't usually try to read the graph like that, like we would on a piece of graph paper. Now if I press graph again, I'll see the graph on the x-axis. It goes from 0, 5, 10, 15, 20, 25, 30, 35, 40. And on the y-axis, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, just like I set a moment ago. So what you would do at this point on your loose leaf is you would sketch this graph, and whenever you sketch a graph, be sure to label the axes. So we would say there's volume on our x-axis, there's pressure on our y-axis. You would include units, milliliters for the volume, and psi for pressure. You would show on your axis the lowest and highest points, the x minimum and the x maximum. So for me, 0 to 40 and 0 to 90 on the y-axis. Then you would roughly, you're not trying to actually plot points like on graph paper, on your loose leaf you would roughly plot the points here. Now let's just try one more thing while we're here. If this truly is what it looks like to me, an inverse hyperbolic relationship, then we can do something to make this graph linear. What we'll do is we'll go back to the stat menu, we'll go back to our lists, which is under the edit option, so option 1. And what I'm going to do is go to the list 3. And what I want to do to make the graph linear is create a new scatter plot, a new stat plot. But I want the new stat plot not to be pressure versus volume, because we just saw that creates a curved graph. What I want now is pressure versus the reciprocal of volume, versus 1 over volume. Notice my volumes are here in list 1. So what I could do is simply type in here 1 divided by 7.3, and that would be the reciprocal of the first data point. And I could continue down the list, taking 1 divided by every volume in list 1. That's a little bit irritating. There's a faster way to do it. If you put your cursor up on top of the L3 symbol, notice at the bottom of the screen it says L3 equals, and I have a number written right there. Do you remember how to clear that? Press clear and enter to get rid of anything in there. Now go back up to L3, so your cursor is on the L3 symbol, and notice now it says L3 equals, and it's just waiting for me to type something. Well, I want to do the reciprocal of the volumes, and the volumes are in list 1. So what I'll do is I'll say 1 divided by, and then L1. And L1, you remember, is right above the number 1 on the keypad, so second function number 1, 1 divided by L1. Another way you might have done that, let me just backspace, I'll delete this. Another thing you might have done is your calculator has a button right here on the left underneath the math button that's designed for taking reciprocals. It says x to the minus 1. So you could have done second function L1 and then pressed that button. And that means L1 to the minus 1, which is the same thing as saying 1 divided by L1. Now press enter, And you'll notice that the calculator fills down that list, list number 3. What it has done for you in one step is simply taken the reciprocal of every volume. So now let's go back to our stat plot option, so second function stat plot. Let's turn plot number 1 off, so I'll select plot 1, I'll move over to the word off and I'll press enter. And now let's go up to plot number 2. We don't have to, we can go back to the stat plot, or right up here at the top of the screen it says plot 2. So if I push the up arrow and then move to the right to plot 2, I can press enter. And now we're at plot 2. Let's turn it on. So notice we saved the graph for plot 1. We just turned it off, but it's still there. And now we've turned on plot 2. Plot 2, we still want a scatter plot, so the first choice. But now our X list isn't going to be volumes, which are in list 1. It's going to be reciprocal of volume, which is in list 3. So let's change the X list to list 3. Second function, number 3. The Y list is still my pressure, so list 2. So we're going to create a scatter plot with pressures on the Y-axis, just like before, but now our X-axis will be reciprocal of volume. If I press the graph button, I won't likely see my graph. Do you remember what we need to do now to see the graph? We press zoom, and then option number 9 down below says zoom stat. This is used for viewing a stat plot. So choose that. Boom. There is our very nice straight line graph. Finally, we might want to know what exactly is the equation of this line. If we knew the equation, we would know the slope, and if we know the slope, we know the value of k, the proportionality constant in the gas law. To do that, let's go back to Stat menu, and notice in the middle option says Calc. So let's go to the right to the Calc option. There are several different kinds of things we could calculate based on the data that we have in our lists. The fourth option is called linear regression. And what that does is it takes data that we have, in this case, list 3 is our x values, list 2 is our y values, and what it will do is calculate the equation of the best fit line, straight line, linear regression, that goes through the data. Imagine that you took a ruler and drew the line through the data by hand, and then tried to figure out the equation of the line by hand. What the calculator is going to do is apply statistical methods to give you the equation of the very best fit straight line. So let's choose option number 4, called linear regression. Now just before we leave this, notice if your graph looked like a parabola instead of a straight line, you would choose number 5, which is quadratic regression. If it looked like the equation of a cubic equation, y equals x cubed, there's a cubic, there's a quartic, which is raised to the power of 4. There's several different kinds of regression, and you would choose the type of regression that matches what you think the graph looks like. So for us, it looks like a straight line, so we're going to choose option number 4, which was linear regression. So choose number 4, and now let's tell the calculator where the x values were. So our x values were L3, so second function L3. And then we're going to put a comma. The comma is this button right above the number 7 on your keypad, so comma. And then tell it where the y values were. They were list 2. Those were our pressures. Now if we press enter at this point, it will tell us the equation of the line of best fit. But we can go one step further. We can make it graph that line for us also. So if we put another comma, and then let's go to this button over here called vars. It stands for variables. So we'll press variables. And we'll notice there's y variables over here. So we'll go to the y variables. And then the first one are functions. So let's choose functions. And notice this looks like those functions we saw earlier under y equals. So we'll choose function number 1. You can choose any of them, but I'll choose number 1. So look at what we're going to tell the calculator to do. We're going to say, perform linear regression, which means find the equation of the straight line of best fit, with our data that's in list 3 and list 2, and that's the x's first, comma, then the y's. And then another comma, we're telling it to take that equation and plot it for us on our calculator as function y1, so that we'll see a straight line on the screen. So let's press enter. So here's the equation of the line, y equals ax plus b. It's a little different from your math class where you might have said mx plus b. A is our slope, so a, 517, would be the value of that constant, the proportionality constant in our gas law. B is the y-intercept. Now ideally a y-intercept here should have been 0, but because we were rounding off the data, because it was a simulation, we're getting a very small negative y-intercept, and that's okay. If I press the graph button now, take a look at what happens. So there's the data that we had, and now the calculator has plotted that line. If I press y equals, there's the equation of the line that we just saw. If we want to clean it up a bit, we can go in and we can delete some of these numbers that we don't need. For example, that's way too many significant digits. So if we simply, instead of point all those decimals, let's just round it off to a whole number. So I'm going to, oops, I just cleared my calculator screen. So what do? Second function, quit, takes me back to the main screen. So it was 517x, and then this is so close to 0, I'm just going to call it 0, or negative 0.1. So if I write 517, and then this button beside the green alpha button that says xt theta n, that's the button I would push to say x, and then I'll say minus 0.1, minus 0.09, I think it said. So there's a cleaner looking equation. If I press graph again, it regraphs, and notice it looks pretty much like it did before. So there's, we've just looked at how to enter data with the stat menu, and number 1, edit, how to use the lists, how to clear data in the lists, how to create a stat plot, right, turning them on, turning them off. Notice if we wanted to go back to the original graph, we could go down to plot number 2, press enter, we could turn number 2 off, the graph that we just had, go back up to plot 1 and we could turn it on, and now if we press zoom and option number 9, we're going to see the original graph that we had here. Okay, so the original graph is still there. If I want to see the second graph, second function stat plot, we would turn plot number 1 off, and then go up to plot number 2 and turn it on. And then zoom number 9 takes us back to our second graph. Alright? If we wanted to, we could trace the line, trace the data, we could press trace there, and notice now it's jumping from point to point, so I can see what the points were on this graph. If I press the arrow buttons, it's going to jump from point to point on my graph. Okay? There's lots of things you can do that are pretty cool with the graphing calculator, but what we've seen there is how to enter data, how to use the data to make scatter plots or stat plots, and then how to find the equation of the line of best fit. If we press second function and then quit right here, we'll get back to our main screen. There's the linear regression equation. So I hope that helps with some basics and using your graphing calculator.